Hi students, I think you can hear me well. Hello, I think you can hear me well. Hello students. Okay. After interval, now it is all about studying of something called zero error. Zero error. So in this vernier instrument, I told you when I was discussing about the errors, I said like there are two errors, systematic error and the random error. I said like in the systematic error in the examples, there are things like zero error and stuff. I told you never write. Now here, once I taught you the zero error of zero error, you can just write zero error is a systematic error. Then you know this is belongs to that area. So it will automatically be completed. Can you understand my strategy? So that is what my strategy, because I'm not forcefully putting the knowledge to you. I let you to gain the knowledge gradually. That is my strategy. Okay. So now it is all about zero error of the instrument. What is the meaning of zero error? Zero error means there is no error. Error is zero. Is that? What did you get by the zero error? So if you read my tute beforehand joining to the class, you may have already understood what is that zero error stands for. Do you have any idea about zero error? Students? Hello? Do you have any idea about zero error? Yes. Good. That means you have read. I'm pretty happy for you and I'm proud of you. You have read others. I told you to watch YouTube stuff even regarding zero error. In the Amrita Lab, that is the best YouTube channel I can recommend for you. India Amrita Lab, they have put like really good animations about this. Okay. Firstly, I will explain you. Yes, yes, yes. Now, this is somewhere it has taken a reading. The size of my nose. It's a very big one, about 31 millimeters, very big. Okay. Now, when I close, now I'm not taking any reading. Why? I have closed the vernier caliper. I kept what uh, movable jaw and the fixed jaw together. You may see even in your ones, this is a plastic one, so can perfectly made. So in the metal ones, there are problems. So why? Zero line and zero line are perfectly in line. Those two are perfectly in line with each other. But as I keep using and using and using, these jaws may get scraped. Again, again, no. So the jaw may slide to the left, to the left. The jaw may have slide to the left. Okay. Jaw may have slide to the left. I hope you understand. The jaw may have slide to the left. See, jaw may have slide to the left. Now, there are some other things like when we just apply many more things and it may get rust. Rust may deposit over there. And when we use this on something like greasy material and kind of like sticky things, those sticky things are attached to these two jaws. So jaw lines may jaws may just move just to the right, just to the right. Now you have closed the jaws, but you are not ready to take any reading. No? Close the jaws means you are not ready to take any reading. but there is a reading to the left or to the right. Understand? Can you understand? Hello? It's not move to. Okay. Now I'm going to erase this one. Write the definition of zero error of vernier caliper. Write a subtopic. Zero error of vernier caliper. Now write the definition. When fixed jaw and sliding jaw in contact with each other, if the scale shows any reading, any reading, any reading, any reading, any reading, we consider like, we consider like, we consider like, what do we consider? What do you consider? We consider like, there is a zero error. There is a zero error. Okay. Let's see what is that zero error. I gave you a very simple definition. Huh? So original definition is like a very weighted. Students were asking me for very lighter definitions. That's why I'm now giving you very lighter definitions. Lighter means key terms are there, but I just reduced the weight. Still the definition is correct. You can apply. Why? Because I gave you the very basic primary definitions. These were not catchy for the students. They were asking me, like sending me messages and asking me, sir, this is difficult. Shall I write this definition? I said, okay. Yeah. If you just interpret it with proper terms, but with the lighter language, it doesn't matter. Okay. But in my midweek worksheets, I will give you the proper definition included. If you would like, you can refer to that. No problem. But if you write this one for the exam, still you get marks because key terms are included. Easy to remember. Right. Now have a good look at it. It is about you keep your sliding jaw and fixed jaw in contact. Fixed jaw in contact. But the readings may give you something like this. The readings may give you something like this. The zero line has shifted to the right. Zero line has shifted to the right. Or zero line of the vernier scale may have shifted to the left. See, to left, here to right. These two are zero errors. This one is a positive zero error. Other one is negative zero error. Negative zero error. Copy these two, please. Okay. Positive zero error and a negative zero error. Now write zero errors are systematic errors. Zero errors are systematic errors. Quickly copy this. Let me know that whether you have completed this. Have you completed this one now? Have you completed this one? Okay. Okay, students. Now we have to go for in detail. Now write positive zero error subtopic. Positive zero error. Write this. Positive zero error is normally taken as a normally taken as a regular reading. Regular reading. It is not a definition. It is an explanation. Okay. Regular reading. Okay. Normally it is a decimal points of millimeter, because if the error is too high, we don't use that. Somehow, have a good look at 1, 2, 3, 4, 5, 6. Enough. Now there is a there is an error. 0, 1, 2, 3, 4, and the fifth line. Not the fifth line. Let's take it like to the next level. The sixth line is in contact. Sixth line is in contact. Okay. What you do is you take the positive error. You mark it like E. Positive error in this way. How? N plus times least count. This is how you take the positive error. Like regular reading. Sometimes the positive error can be come up with the main scale division as well. Main scale reading plus n times least count. But this is a very huge error. But right, sometimes it may come. Like if the zero line is placing somewhere here now, 2 millimeter is there, but we don't use that type of ones. But questions may come like that. Practically, we don't use something like that type of damage, but questions may come. Copy this. How to make this error now? This error is, positive error is 6 times 0.1 millimeter. That's going to be 0.6 millimeters. Understand? Understand? Learn? Understood that? Okay, quickly. Okay, Lamai? Right. Now let me know, uh, explain you how to remove the positive error. Now, right? Copy this one too as an example. Copy this one too as an example. How to remove positive zero error. Right. Imagine this is my actual height. Okay. This is my actual height. It is about this. Okay. So if I want to take my height reading, so if there is a place which is marked with the scale that I would like to take height. Now this is my height, actual height. This is my actual height. But now, if there is a certain condition, scale is like this, but I'm taking reading from a certain point where it is like a step on a stair or something like that. So now I'm taking my height. I get some extra. This is my regular height, real height. This is my reading. This is my reading. This is my reading. Okay. So you can find that there is an error that is a positive error. How can I remove this positive error from the reading to get the real height? How can I get the real height? Tell me. Subtract the error from value. Okay, good. Okay, it is like this. See? Now on my toss. So I'm getting a really big height now. So it is not my real height. So I have to subtract. Like the same way, here I have to subtract this. So the real reading, actual reading is actual reading is reading subtract positive error. Reading minus positive error. Copy this. Reading minus positive error. Reading minus positive error. Copy this. Reading minus positive error. Okay, students? Hello? Understood? Reading minus positive error. Now, okay. Let's go for real example. If this caliper given in the example 1 is here. Okay. Example, read the reading of 3.38 centimeter 3.38 centimeter 3.38 centimeter. What is the minimum reading? Sorry, what is the actual reading? Okay. Now find the actual reading and tell me. Find the actual reading and tell me. Very easy, very easy. Once you catch this one, you can go very fast. Very good. Very good. The reading is what? Actual reading is the reading minus error 3.38 centimeter minus 0.06 centimeter. You have to convert this to centimeter. Okay. Centimeter. Now the reading is going to be, actual reading is 3.32 centimeter. I hope you everybody understood it. Okay. Copy this. Okay, students. Right. Now write negative zero error of vernier caliper. This is something really you have to consider really with more attention. I will tell you what is the reason for that. The reason is this is not like direct reading. Now write in a new line, there is a special method of doing it. There is a special method of doing it. I will erase the bottom part. Okay. Before that, I will go for that those two here and hold by my hand. Now it is a very weird way. Have a good look at. Now I am expecting it to be like this. Zero line of the main scale to be in line with zero line of the vernier scale. But for some reason, it is just moved somewhere here. Now let's see which line is in contact. You can clearly see now the ninth line is the one in contact. What line is in contact? Only the ninth line has contact. See, ninth line is in contact. Did I actually move 9 lines? 9 small divisions? Did I actually move 9 small divisions? Tell me. It is like reversing a vehicle. Reverse again. No. How many lines did I actually move? If you look at here, see, only a one line, only about one line, but it shows 9 lines. Is that correct? Is that true? Is that valuable? Yes or no? Hmm? No. Now I will move it forward furthermore. Now see, it is showing 7 lines. Have I actually moved 7 lines? So see, it's a very narrow gap, not like a 7 line gap. No. How many lines have I actually moved? Only about 3. Okay. Now see, it is very weird now. It only shows third line now. Is that fair? It has gone so far. It has gone so far. Now it is only showing the third line. Is that fair? Yes or no? Students, is that fair? Hello, students. No, not at all. So what is the reading then? What is the reading you expect? It sounds like 3. What is the reading you expect? Tell me your guessing reading. If you are wise enough, you can just guess it correctly. Sounds like the third line. What is the actual reading it should be? Hello? Can't you guess? What is third line? No, no. Third line. It is the third line. Only 10 lines are there. Only 10 lines are there. Only showing like third. It is gone back. Long way back. Okay. Forget about this. You understood for the first part, no? If it looked like 9, actually one gone. If it looked like 8, it has actually gone 2. If it looks like 5, it has actually gone 5. Okay. Now it is in the reverse. If it looked like 4, it is not 4. It has actually gone what? 6 parts back. Can you understand? Firstly decreasing, now increasing. If it looked like 3, now guess. Guess it now. 7. If it looked like 2, 8. If it looked like 1, it has gone 9 parts. So there is a very, 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 very simple way to do that. Right? That to find the negative zero error, you have to follow the following step. You have to follow the following step. Have a good look at. Negative error is capital N minus simple n by least count. Do you feel afraid after seeing this one? Amen. What is this capital N stands for? If you are wise, you can tell me what is this capital N stands for. No. Total number of divisions in the vernier scale. Very good, Tejaswin. Good boy. Capital N stands for total number of what? Divisions. Divisions in where? In vernier scale. Okay. Simple N is what? Coincided line. What line? Coincided line. Number. Coincided line number. I will draw something like this. Here, you can see it as if the fourth line. It's gone back. So it as if the fourth line. We know that it cannot be fourth line because it has only moved a very small, bigger distance than 4. So what can you do now? Firstly, copy this one and then listen to me and you can draw this later. Did you copy this part? Did you copy this whole part? Did you copy this? Okay. Now have a good look at how I'm going to find out. Negative error is n is 10, normally 10 total lines, minus 4 times 0.1 millimeter. Okay. What is my result is going to be now? 10 minus 4 is 6. So the error is going to be 6 times 0.1. Answer is 0.6 millimeter. But that is the negative 0.6. It is the minus 0.6. Understand? Negative 0.6. So now draw this one and write all these steps and come to this answer. I will rewrite it over here. Negative error equals to 6 times 0.1 millimeter. Error is minus 0.6 millimeter. Okay, copy this. Okay, lamai? Copying or copied? Students, copied. Okay. I need two more confirmations. Copied. One more confirmation. I normally take three people's results. Okay, I'm satisfied. Now have a good look at. Now in this condition, that I am actually like little bit below the start of the reading. So my height will be taken here like little bit shorter. I feel really upset now. It is a negative error. What type of error? A negative error. So see, I'm again marking my height. It is to be somewhere here. Now I feel like somewhere here. I feel really upset. Now I check what happened here. Actually, the reading started a little bit above me. I'm just below. Now what can I do to get my real height? What can I do to get my real height? Because I have taken the reading lesser than my height. Add the error with real height. Really good. Now you can just write it like this. That's why I kept it. You are removing the error. Removing means subtract. But with the negative sign of the error. So negative and negative finally added up. The actual reading is what? Reading plus error. Copy all of these. This diagram is useless, but copy these. Okay, Ramai? Hello? Done? Okay. Now write a reading of 3.38 centimeter. Reading of 3.38 centimeter was taken by this instrument with above error. Above error means this one. Above error, above zero error. How to rectify the error? How to rectify the error? Let's see. අග්ගලා කියන්න පුළුවන්. මට හිතෙනවා තේජස්වින්ලා එහෙම දැන් සිංගල් ආන්සර් එක දායි. Let's see whether someone just can tell me the answer. Class? No, class, no. I think class is died. Sanuri. Good girl. Yeah, Sanuri, good. Others? This time Sanuri is the best. Anuhas. Reconsider. Charaka, correct. Okay, students. What you have to do is mind calculation. It is a mind game. No need to waste any pencil line to do these type of things. The actual reading is 3.38 centimeter plus 0.606 centimeter. Your answer will be 3.44 centimeter. Very easy. Shall we quickly move on to that board, that so-called graphic board, and do? Are you ready? Father, ready there? Am I? Hello. There are questions to be done. Are you ready? Quickly. ඕමවින්ද අපි මූවෙමු බෝඩ් එකට. Hello students. There are certain zero errors to be you to find. Firstly, let's find out these all 5 zero errors. Let's find all these 5 zero errors. Okay, Lamai? There are like 5 questions. Yeah. Let's try all 5. I will give you time of like 1 minute for each. That's more than enough. Going to give you 5 minutes and let's try. Quickly start it. Okay, Lamai. I'm going to explain. Let me enlarge all of these. I will start to do the first one with the worked example. See the number of line, not the first one, not the second one, not the third one. It is the fourth one. Now have a really good look at how to take the, it is a negative error because it's gone to the left. I told you negative error, you are not directly read it like that. So the negative error equation is n minus simple n times least count. Now have a really good look at number of lines is 10. The coincided line is the 4 multiplied by 0.01 centimeter. So it is going to be 6 times minus 6 times 0.01. Answer is 0. Minus 0.06 centimeter. I hope you understood it. The worked example. Now in the second one, you can see it has moved to the right. It has moved to the right. So here, it is a positive error. I told you the positive error equation is n times least count. So how? Not the first one, second one, third one, fourth one, fifth one, and the sixth one is yes, 6 times 0.01 centimeter. So the answer is positive error is 0.06 centimeter. Or in millimeters, 0.6 millimeter. You can leave the answer in either way. If you couldn't copy it, I will give you 10 seconds. Now let's go back to here. It is a negative error again. Minus error is equals to, what is the number of line? It is the sixth line. 10 minus 6 times 0.01 is like minus 4 times 0.01. Answer is minus 0.04 centimeter. Very easy. Okay, it is very, very easy. Take your 10 seconds and write it. Now the next one. Again, a positive error. You can see it is the third line. 3 times 0.01 centimeter. Answer is 0.03 centimeter. Very, very simple one. Previous one, let me write the answer here. Negative error equals to minus 0.04 centimeter. Now here, see, again it has moved to the left. That means the negative error equals to, which line has gone coinciding? It is the seventh line. 10 minus 7 times 0.01 centimeter. So the negative error answer is minus 3 times 0.01 centimeter. The answer is 0.03 centimeter. Now the last one, I will give you 10 seconds to you to write it. Okay. Now, right here, you can see it has gone whole one line and it is the 10th line also. So the reading is 0.1 centimeter or 0. Sorry, yeah, millimeter or 0, yeah, 0.1 centimeter or 1 millimeter, 1 whole millimeter. Okay, Lamai, that's done. Now let's quickly go for the next part. That is the most ultimate understanding I need from you. There are only 2 questions. There are 2 example, sorry, 1 example. There is a 1 example There are two questions. I need you to do this. Then I'm pretty sure you can do anything with the vernier caliper. For this, I will give you 4 minutes for you to try. You have a time of 4 minutes. I'm starting your timer. Start to do this. Senori, Kanishka, Charaka. Good. Now everybody seems to be understanding this one. No? Great. And also I have to tell you, you will gradually understand the importance of this board. Let me explain you the very first. Yeah. Okay, Senori. Very first example calculation here. Now the zero error, it is to the left. So that means it's the seventh line coinciding. So the error is a negative 10 minus 7 times 0.01. So that means minus 3 times 0.01. The error is minus 0.03 centimeter. That is what it's given here. Now there is a reading. There is a reading. In the reading, we read the reading in main scale reading plus vernier scale reading. Here the main scale reading is 0. 0 plus. What is the vernier scale reading? It is the sixth line. 6 times 0.01. That means the reading is 0.06 centimeter. Now you have to remove the error. I told you the actual reading is reading minus error. So the reading is what? 0.06 centimeter minus 0.3 minus 0.03 centimeter. Now it is going to add up together. Now it's going to be 0.06 centimeter plus 0.03 centimeter. Finally, the reading is going to be 0.09 centimeter. This is the example one. Now let me go for the other ones. It is a positive error. Firstly, read the error. Third line. Error is positive, but 3 times 0.01. It is 0.03 centimeter. That's it. And in the reading, it has gone past the per centimeter. Okay. This is the main scale reading, MSR. Okay. Now the reading is going to be, how to take the reading? Reading is 1 cm plus, we can write, wait. We have to write it like in the proper way. The reading is equals to 1.0 centimeter plus, what is the line coincide? Sixth line. 6 times 0.01 centimeter. It is going to be 1.06 centimeter. Right. Now I want to correct my reading. The actual reading is how? 1.06 centimeter. It was a positive error. So in the bracket, answer is 0.03 centimeter. My answer is going to be 1.03 centimeter. Can you understand it? Understood this one, students? Understood this? Hello, students. Now the zero error, again a negative one. So the negative error is what? 10 minus, what is the reading coincide the fourth one? Multiplied by 0.01 centimeter. So the error is minus 6 times ugly. Minus 6 times 0.01 centimeter. The error is minus 0.06 centimeter. Now this error is minus 0.06 centimeter. Now I want to take the reading here. Okay, now it will check your real understanding power here. Have a good look at. Now it is like 6.9, 6.8. No, not to go like that. It is something with 6 now. This will be 6.5. Why? The large arrow, sorry, large line is for 0.5. 6.5, that means 6.4 is the main scale reading. This is the MSR, main scale reading. So what is my reading here? The 6.4 centimeter plus the vernier scale reading is the third line, 3 times 0.01 centimeter. It is going to be 6.43 centimeter. Now the error is a negative error. I need to add them together. Actual reading is 6.43 minus 0.06 centimeter. That means you have to add finally. So my result is going to be 6.49 centimeter. Did you get this answer correctly? Hello, students. Okay. Right, great. So it is like 11, 18. 18 past 11. Now, are you ready to? I'm asking like, are you ready to take the very last theory that is about the extended vernier caliper? It will only take like 2 minutes, 3 minutes to explain you and do few simple questions here, at least like 2 parts of that. Are you ready? If you are not ready, we can learn in the next day. It is 20 minutes past 11. If you are really sleepy or whatever, now tell me. I'm like a vampire. I can stay awake for many long hours, but I don't know about you. This is the first time I'm going to teach something to you. I only did calculations so far in this board. Now I'm going to teach a certain part in this board. You are fine with it? Okay. Young blood, no? Okay. Now write quickly. Extended vernier caliper. I will make the background even more user friendly. Do you like this background, the black background, black dot background, black line background, pure white background, or black? What do you like? Black ටිකක් බලන් ඉන්න පුළුවන් නේ. Black ටිකක් අර ඇහැට බලන් ඉන්න පුළුවන්. It's eye soothing. So let's go with the black background. Okay, students, now I am going to introduce you the certain condition called extended vernier caliper. Extended vernier caliper. Extended vernier caliper. The letters are also very distinguished. Okay. Now write the knot. It is not a definition. Write a knot. Sometimes vernier caliper can be used to find readings with more accuracy. Because in a regular, okay, write this, more accuracy, right? Because in a regular vernier caliper, sometimes, I'm telling that from the beginning, sometimes vernier caliper scale can be used to measure readings with more accuracy. Okay, more accuracy. Okay. All right. This can be done by lowering the least count. Lowering the least count. Since the regular vernier caliper can measure readings with the minimum level of 1 centimeter. I will show you why. I didn't show you because it's understandable. Percentage error equation is what? It was least count over reading multiplied by 100%. Now have a really good look at. The margin is 1%. Least count was 1 millimeter. Sorry, not 1 millimeter. 0.1 millimeter. 0.1 millimeter. Okay. Least count was 0.1 millimeter. So the minimum reading is something I don't know. So multiplied by 100%. So let me show you. So what is the minimum reading in a vernier caliper? Now have a good look at 0.1 millimeter multiplied by 100. So the minimum reading is 10 millimeter, or I can say it like the minimum reading is just until to 1 centimeter. You can't measure anything smaller than 1 centimeter. Can you understand? Can you understand? Everybody, can you understand? It is the same mechanism what we did for meter ruler. In the meter ruler, we found like it is for like 10 centimeters. Here it is 1 centimeter. Right, okay. Now you should measure something smaller than 1 centimeter. So how can you do? We have only one option is lowering the least count. Now, right, in an extended word, copy this, please. Copy this. I will give you 20 seconds. Copy this fast. Copy this fast. Done copying, students? Done copying, students? What doing? Hello, students. Done. Right. Now, right. In an extended vernier caliper, there are many multiple ratios. A common one is dividing 19 millimeter length into what? 20 equal parts. Now you know what to do. That vernier scale is made out of something like this: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. You divide this into 20 equal parts. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Like that. Okay. You divide it into 20 equal parts. This is the 19. It is an extended. Loku karatika. Let's see. VSD. How to find the VSD? 19 millimeter over 20. You can leave it like as a fraction. Leave it like a fraction. Leave it like a fraction. Don't get it to a decimal number. Leave it like a fraction. Now tell me, what is the main scale division? MSD. It is as normal as regular conditions. 1 millimeter. It is a 1 millimeter. Right? Now, what is the least count of the vernier caliper? How would you take? You subtract main scale division by vernier scale division. Very simple. How would you do? Main scale division is 1 millimeter minus vernier scale division is 19 millimeter over 20. Now you can do cross multiplication. Cross multiplication means you have to multiply this and get a common denominator. So 20 millimeter minus 19 millimeter over 20. If you don't understand that math part, let me know. I will explain you with a simple mathematical example. If you don't understand that mathematics I did, let me know, because it is a grade 7 or 8 maths. But if you have forgotten, I can teach you quickly. Students, I will give you an appearing time of 10 seconds. Right. Nobody needs, I'm pretty sure. Right. Now it is going to be least count 1 millimeter over 20. So the answer is 0.05 millimeter. Understand? Understand? Students, understand? Yeah, correct. So this is the least count for my instrument that I sent you. I will tell you a way how to read that one in a later time. In the vernier caliper you got, you have this reading scale. You understood this, ne? Copy this one. That's why I told you I am taking a little more time and plant the knowledge perfectly into your head. Then nothing would happen to you because you have a perfect knowledge. There are certain MCQ techniques we have to do in that one in next class. It is not the right time to do that today. But in the next class, I am going to completely discuss about micrometer screw gauge and getting certain start to something spirometer. So let me give you certain thing. Just find certain all DVD, right, and mark like this, and divide it like this way. One is like starting from 0, 5, 10, 15, like 20, 25, 30, 35, 40, 45, and I have drawn many two lines. You are not writing any 50, leave it like this. And another DVD, you are going to do that for the opposite side, opposite direction. Clockwise and anti-clockwise. 0, 5, 10, and like 40 and 45. This anti-clockwise numerical order. Here the clockwise. Okay. I'm telling you to do this for certain reason. Find out an old DVD, use a marker pen and mark this way. Okay. I will be able to explain you the screw principle very simply if you have these two DVDs with you, all DVDs. And also, I want you to find out if you can uh, this type of bolt and a nut. Big one is much better if you can find nut and bolt. So you will be able to understand what is this screw principle perfectly, right? Okay, students, I'm going to explain you thoroughly about this one altogether. So now, shall we do the questions? of that one or wind up the class. Whatever you would like. I would like to do at least the it until to the second Roman number at least. Are you ready? Because the time is already gone, but we are in A level. I would like to do a lot of work if you are ready. But if you are not ready, we can just hello students. අනේ නිදිමතයි. හරි. මම මේ දෙක කරන්නම්. මම කරන්නම් ඔයාලා බලන්න. හරි. අනේ නිදිමතයිලු. I am going to do, you can just have a good look at. Length of 1 unit of the main scale, 1 millimeter. It is given. Length of 1 unit of the vernier scale, 9 parts of divide by 10. 9 millimeter divide to 10. It is going to be 0.9. Please count 1 millimeter minus 0.9 millimeter. So the least count will be 0.1 millimeter. Right. I did this part just in the previous page. So now I am not going to do that again in that page. I skip that one and go for the next one. The length of main scale, 1 millimeter. Oh yeah. Now the length of the vernier scale, let's do it. VSD, have a good look at how many parts? 49 parts. Of what? Millimeter. Divide into 50. So my answer would be what? 49 over 50 millimeter. Or you can make it like a equivalent fraction, 98 over 100. Equivalent fraction අමතක කට්ටිය දෙකම දෙකෙන් වැඩි කරා. Right. That means 0.98. Now I want to find out the answer for the least count. How can I find the least count? Very easy. How? 1 millimeter minus 0.98 millimeter. This system is more accurate now. You will see why. The least count will be 0.02 millimeter. I'm sure you got all about vernier caliper now. That's why I'm telling you, if you listen to me, you can understand anything. Okay. And also you learned another thing. This board will help you more faster learning than regular whiteboard. Okay. So let's get hybrid method. I'm not completely doing on here. So in necessary, I will move to this one and explain. Okay. Let's wind up the class for today. God bless you all. Bye. Class is over. Bless you. Good night. Bye. If you'd like to get a printout and do it. If you'd like to. It's up to you. Let's wind up the class. Bye, Lamai. God bless you.